2023 was an amazing year for my YouTube channel. I started this year with just over 1,000 subscribers, and just recently we hit 500,000 subscribers, which is crazy. And the most popular series on my channel this year was definitely doing your guys' suggestions in Universe Sandbox. So to celebrate the end of 2023, here are some of the best suggestions you guys gave me this year. Vexter96 from my Discord says, explode a black hole. Let's actually, okay, we're gonna turn the sun into a black hole and then explode it. So if we lock the mass, but then turn the radius down enough, we're gonna crush it into a black hole. Okay, sun is now a black hole with the same mass as it had before. So the planets will actually stay in orbit, but they won't have any more heating. And okay, now we're gonna go to tools and explode. Let's slow down time because it's going pretty quick. And we're just gonna click on it and it will explode. Oh, goes supernova. Supernova going out. Extends throughout the entire solar system. It looks like it's gonna go, yeah, completely engulfs the solar system. All the planets burn to death. All of the inner planets are already dead. Pluto survives. Go Pluto, somehow. Let's speed up time and see how Pluto ends up. So all of these planets are going to turn into rogue planets. There's going to be nothing holding them. So they're all just going to fly out in their own directions and be completely alone in the universe. Pluto will just freeze over, and it looks like it does survive though. Epic Gamer says, make the planet J1407b Super Saturn. So if you didn't see my Space Engine video, I went to this planet in Space Engine, and it has the biggest rings in the universe that we've discovered. So let's make it. So let's start by searching J1407. And this will give us the star. This is the actual star. And here is the planet. So let's put the planet, I don't know, a good ways from the star. And the planet is actually so massive that it starts to heat itself up. So I'm just gonna pause it so it doesn't do that. So to make it have its rings, we're going to start by putting this ring here, and then let's adjust it. So the rings actually go out 180 million kilometers. So we're gonna switch this to kilometers, and we're gonna type 180 million. 180, 000,000. Here we go. Let's add the rings. Boom. Okay, it's starting to lag, but here's how big the rings are, which is crazy. Oh, it's like 5 frames per second. This is how big the rings are. Let's play and see what happens. How fast can we run it? Oh, we can't run the simulation fast at all. But there we go. That's J1407b in Universe Sandbox. That's how big the rings are. Back in the center of the solar system, and our next suggestion says, try to destroy the Earth with only Tesla Roadsters. You can mess with the settings of the Roadster, but you can't change what you're using. Okay, so our cold Earth is now gonna get a lot warmer because of the collisions we're about to put it through. So in Universe Sandbox, they have a object called a Tesla Roadster, and so we're gonna try to destroy the Earth only using these objects. Okay, so we're gonna launch the Tesla Roadster into the Earth, but we can change the settings on our Tesla Roadster, so we can make it very, very big. Just take that slider and drag it up. Okay. If I'm zoomed out enough to see the Earth, I want to be able to see some of the size of this Roadster. That's how big I want it to be. Perfect. See that? Okay, that's what I'm talking about. So let's set our time back to pretty slow, and let's see if this is enough. I don't think it will be, but let's see if this Tesla Roadster can do something to our Earth here. Here we go, collision time. You can see the reflection of the stars on the Tesla Roadster. It's so shiny and clean. But let's see what happens. Oh, okay. Crater starting to form, and it's going inside the Earth, shooting off fragments. Okay, Africa is a desert, but it's always like that. So nothing really changed. Okay, let's see if this can melt the oceans, actually. That'd be cool. Whoa, it's working. Look. You could see certain areas where the water has melted from its ice state back to its liquid state. So let's speed up time and see the state of the Earth after this. So it looks like anywhere where there was a collision, the water's melted, or the water's completely burned off. And it looks like, whoa, the water. Okay, let's see if this helped the life likelihood, because it was at 0. No way, it brought it back up to 43.7. So if you have a frozen Earth, just throw a giant Tesla Roadster at it, and that will help your chance of life. It's going up still. How high is it gonna go? It like heated up the core of it enough. It's going up to 80. Okay, it's dropping now, but it almost got to 80% chance of life by throwing a Tesla Roadster at it. Look, the entire continent of South America is melted. Look, it's like there's more water. The Earth seems more flooded. Yeah, because a lot of the continents are covered in water. Interesting. There's the giant ring. It looks like a portal. Okay, that is not destroyed yet. We need some more. This time we're definitely going to destroy it. Don't even worry. Okay, this has got to destroy it. Look at the size comparison between the Tesla Roadster and our Earth. It's like 3 times the size of the Earth. It has to destroy it. Oh, yep. It just absorbed the entire thing. And now our Tesla Roadster has the mass of more than one Earth. That's what it would take to destroy the Earth. Now, instead of the Earth, we have a giant Tesla Roadster orbiting in the Earth's place. Okay, and then our last suggestion for today is to make a black hole so big that it makes the Big Bang once again. So to do this, we're gonna turn our Kepler-90, our poor little system here. I actually have fun with this system. We're gonna turn it into a black hole that is super big, a super massive black hole, and then we're gonna explode it, basically recreating the Big Bang. So mass, we're just gonna turn this up super high until it turns into a black hole. So this is gonna start eating everything we've created. You could see all of the ring particles either being shot out or eaten. Oh, and there it goes. It's a black hole and it's eating. Oh, yep, everything's being eaten. Okay, so how many galaxies are there in the universe? 200 billion galaxies. So if we set our mass to 200 billion, so 0.000000000, I think that's billion. Okay, so now this black hole has the same mass as every single galaxy put together. So if we explode this black hole, technically all the matter flying out should be able to form galaxies just like the Big Bang did. Okay, I exploded it. If it doesn't crash the game, let's see what happens. Oh, it might have not worked. It says the supernova is here, but I think that we're so far away that we can't really observe anything happening. Okay, you can see it moving, but you can't actually see I think the game can't simulate it because it's just so big. Okay, our next suggestion asks if we can remove the black hole from the center of the Milky Way galaxy. So let's pull up the Milky Way. Okay, here's the Milky Way. So Sagittarius A right here is the center of the Milky Way. So let's try to delete it. Delete. The entire galaxy just kind of went dark. So there's no supermassive black hole now at the center of the Milky Way. Let's speed up time really fast and see if it all falls apart or what happens to it. Yeah, look at that. All of this intersection isn't being held in by that black hole and the entire galaxy just spirals away and everything leaves. That's interesting. Wow, that was cool. Okay, our next suggestion is to spin the Earth faster and faster until something happens. So you can still see the rotation of the Earth. The Earth is rotating, but let's make it go faster. So I think there's a tool for this. Force, spin. Oh, yeah, look. We can start making it spin. Whoa. Okay, if we start making it spin a little bit, the centrifugal force pushes the water away from the land and towards the equator, it looks like. Yeah, look, all the oceans are starting to go towards the equator because it's like when you spin around really fast with your hands out and you could feel all the blood rushing to your hands. That's what it's like. How fast is it going? So 1 day on Earth right now is just 1 hour. So it only takes 1.6 hours for the entire Earth to rotate fully. So let's make it go a little faster. Oh, okay. So we started spinning it so fast that chunks of the Earth are pulled. The centrifugal force is stronger than the force of gravity and it starts to pull off chunks of the Earth. Let's go faster and faster. Even more, start spewing out now. Oh, come on. The whole Earth is just spewing out all of its matter. And there we go. We spun it so fast that all of the matter shot out. And then now we're just left with this like molten core. Can we spin this too? Oh, we can. We can do the same thing with this, with the core. Keep going faster. Yes. And that's it. That is it. Oh, it just focused on the sun. Where is our mess of parts? I don't even know. That's what happens if you spin the Earth super fast. All right, we got a suggestion from MSAW, I think. Make white hole. We can try. So Universe Sandbox does have black holes, so let's throw in Sagittarius A, which is a supermassive black hole at the center of the Milky Way. So here's that, and you can see the effect that a black hole has on light, and this is accurate. If you actually saw a black hole, that's what it would look like. And to make it white, we could try to do negative mass instead of a positive mass. Well, it worked. Let's also set its visual to white. So it's shooting out white light now, and so the theory is that white holes shoot stuff out instead of suck things in. So if we put an object here, let's put Jupiter still right here. It should shoot Jupiter away from it. Yes, see? Instead of sucking it in, it shoots it away. So let's, I'm gonna add rings to this. So we got a bunch of rings going on here. It's getting kind of laggy,
But as soon as I hit play, they should all shoot away from it. So let's see if that happens. Let's slow down time. Okay. There they go. And yes, it's like a ripple. They all get shot away out of the white hole because the negative mass on it. That's pretty cool. All right, we did it. All right, we got a suggestion from Mustafa Hamadi. Make the biggest star in the game explode. The biggest star ever known is Stevenson 218, which is right here. And this may not look that big until you compare it to the sun. Here's our star compared to Stevenson 218, and here's Earth compared to those two. So Earth compared to the sun compared to Stevenson 218. And let's make it explode. So to get some scale, I'm actually gonna put the Earth 1 light year away. So the Earth is now 1 light year away from Stevenson 218. I wonder if it still is getting light on it. Very dim. So it's still like lighting up the surface even though it's this far away. But now let's play the time and let's go to Stevenson 218 and we're gonna go to tools and explode and we're just gonna click on it. And this is a little bit faster than real time. We'll speed it up. And this is the supernova that comes off of Stevenson 218. And Earth is all the way out here. So we're going to speed up time. And you can see that this supernova is going to extend all the way out to the Earth, which is a light year away, and keep going. So I wonder what is going to happen to the Earth. So the Earth obviously freezes because it's so cold out here. But yes, this supernova is now massive, many light years across. You can see the radius right here. So it's 10 light years across about. So let's see how big it's gonna get. Okay, it looks like it stops right there at 4% the entire galaxy, which sounds like not that very much, but let's put the Milky Way in here. So here's the Milky Way, and that is how much space it takes up in the Milky Way, which is an insane amount if you actually think about the size. That's crazy. All right, we got a suggestion that says it would be cool to see the biggest planet orbit the smallest star. Okay, let's open a new simulation for this one. Okay, HD 100-546b is the biggest planet we have ever found, and you can see it's 17.5 times the mass of Jupiter. So now let's make this planet orbit the smallest star. Okay, so they don't actually have the smallest star in the game, but it says it's smaller than Saturn. So let's just make a star and make it smaller than Saturn. So here's Proxima Centauri, which is already a fairly small star, and we'll just like shrink it. Okay, we need Saturn for comparison. Okay, that's smaller than Saturn. That counts. Okay, so there's Proxima Centauri. These about the same size as the smallest known star. And then now let's get HD 100-546b. Boom. Okay, so this is the biggest planet orbiting the smallest star. That's what it looks like. They're kind of pulling each other. And it looks like it's getting really hot, probably just because HD 100-546b is super big already. Let's zero the velocity and just have them collide. Oh, boom. Okay, supernova. HD 100-546b survived, and Proxima Centauri actually died. That's funny. Pokaholic says, would be cool to see a binary black hole system. All right, let's try to make a binary black hole system. Okay, so this black hole has the same amount of mass as the sun, even though it's going to be a lot smaller than the sun. Let's turn on... Okay, I turned on a green background so you can see it better. There's a black hole that has the same mass as the sun. So let's get it in a binary orbit now with another black hole about the same size as the sun. Okay, they're going. We'll create a barycenter. So they're both orbiting around this point. So you can see it's working. So there's two black holes orbiting each other. So now we should be able to put a planet out here. Let's put Jupiter. About this far, I guess. And let's speed up time and see if Jupiter will be able to orbit safely. Yeah, it looks like it. So the entire system's moving, so that's why you get this like trail, but you can see that Jupiter does seem to be pretty stable. So now let's give Jupiter a moon and make it habitable with tidal heating. So with realistic lighting, it is super dark out here, but let's give it a random moon and put it fairly close. I'm gonna turn on the flashlight just so we can see what we're working with. Oh, this already looks like it could be habitable. Let's check its temperature. Okay, it's cooling down, so we need it to be closer. How's that? And then auto orbit. Okay, we may need the mass a little bit bigger. All right, here we go. This moon should be habitable. 8.5% habitability. Slowly going up over time, so it should work okay. So yeah, there's a binary black hole system. Pretty cool. Could you do dark sun? It would be so cool. Okay, so let's make the sun dark. Luminosity, 0. Okay, well, it still looks like the sun, even though it's not giving off any light. So we need to change the visuals. Boom. That is a dark sun. It looks like a black hole now. Okay, let's see if this actually makes it dark. Is the Earth freezing over? Oh, look, it is. There's no light over here. It's so weird, though, because it thinks that there should be, so there's no city lights on this side. Whoa, interesting. Oh, yeah, look, the whole Earth is freezing over. Let's speed up time and see how long it takes. And after a few years, yep, the entire Earth turns into a big ball of ice. But the sun is still here, and it's dark. A dark sun. It's like a black hole. Pretty cool. Combine the Milky Way with a random galaxy that's 10 times bigger than it. Let's do it. Okay, Milky Way, go. And then we'll do random spiral galaxy here. That already looks a lot bigger. Okay, radius, 10 times the size of our galaxy. Okay, so that's Milky Way versus a galaxy 10 times as big. It looks more than 10 times, but let's just play and see what happens. We're gonna need a lot of time warp here. Okay, things are starting to move. Here we go, Milky Way. Here it goes, it's being pulled. Oh, Milky Way's disintegrating. Oh, the whole Milky Way just got eaten, basically. Okay, wait. Is this the Milky Way? Yeah, this is the Milky Way's black hole. So it still it did disrupt the big galaxy, even though, okay, the black holes are in orbit of each other now. In a binary orbit, and as they orbit each other, it completely shreds the combined galaxy now. Shooting stuff off into space. Wow, okay, so this is as fast as I can run it, so I'm just gonna run it for a little bit and then see what happens. So it looks like it's just shredding the black holes over time. And I guess they'll clump back together and sort of form a cohesive galaxy. That's really cool. Alex's thing says, give Earth more moons. Okay, so let's go to the Earth, and if we want to give it more moons, what we can actually do is add a ring and do a moon sphere. Moon sphere right here. So this will add, let's pause it, moons all the way around. Over 100 moons. I don't even see 150 maybe. I don't see any above that. So let's unpause time now and see what's gonna happen. This is a lot of moons for the Earth. Oh, it looks like it's going okay right now. It looks like some are gonna crash into each other. Let's see. Oh, they're gonna all like condense into the same plane. Oh, that's not good. Crash. Tons of them just crashed. A bunch of them hit the Earth. The Earth is dead. Let's see what happens. Earth gets hit, bombarded by all these moons. Looks like some of them are gonna go into orbit. Some of them escape. So let's turn on the orbit lines and we'll see how, look at these orbits. So a lot of them actually are still in orbit, and Earth looks like it will survive after a long time. With, again, new continents. Oh, it looks like it got spun so fast that the centrifugal force pushed the water to this ring state. So it's gonna be like desert at the top and bottom, and then all the water is gonna be at the equator. That's pretty cool. Jack Plays says, make a planet with 100 moons. Okay, let's try it. So let's add a star. Put a star in the middle here. That'll work. And let's put a planet around it. We'll do a gas giant because gas giants typically have more moons. So here's our gas giant. We're gonna name it Home of the Moons, and we're gonna want some cool colors on here. So let's make it red. Let's do a red gas giant. So I'm gonna start putting in some red color on the bands, and I'll see you guys when it's done. Okay, so here's a red gas giant now with a little bit of yellow, and we're gonna add 100 moons to it. So I'm gonna do it while it's paused, and then once it's done, we'll see if they all survive. So I'm gonna count, and we'll get through this. 1, 2, 3, 4. 100. Okay, there's 100 moons. And if you turn on the orbital view, you can see how many there really are. I will be surprised if this is stable. Let's play and see what happens. It looks like they are shifting slightly. Okay, there was a collision there between two of them. And in reality, that would cause rings. Okay, I saw another collision. Collision. It looks pretty chaotic. So I'm gonna speed it up as fast as it'll let me. And after a while, we'll see the status of it. Wonder if any of them escaped. Yes, a bunch of them did, it looked like. But a lot of them are staying intact. Okay, so this is about 10 years later, and you can see the orbits on them are very chaotic, very elliptical when they all started, very round, but most of them are still orbiting, and it seems like it would be pretty stable over time. So now what I'm gonna do is increase the mass on this 100 times, and then watch what happens. So increase the mass and go. And they all get sucked into it, and it lights on fire. And it ate them all. And then all of these escaped, so I guess they survived.
Okay, our next suggestion says make Earth have 15 moons and see what will happen to the orbit of Earth. Okay, so we're gonna pause it. 15 moons, it says different size and mass. So we're just gonna go random moon. We'll see what happens here. We're gonna do some pretty big moons. 1, 2, 3, 4, 5, 6. We'll go up and around. Okay, is that 15? We'll do a couple more to be sure. It's at least 15. 3, 2, 1, go. Oh no, we went way too fast. But you can see it threw, just that threw Earth out of the solar system. Let me do that again and we'll do it slower. Okay, we need this to be a lot slower, like 2 hours a second instead of 16 days every second. Yeah, that's better. Okay, pause it. We'll do this again. Random moons. We'll see if the same thing happens. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 very large moons. And we will go a lot slower this time. Here we go. See what happens here. Oh, that one almost hit Earth. You can see lots of eclipses happening. Oh, 2 collided right there. There's an eclipse happening. Another collision. Oh, 1 hit Earth. That's not good. Okay. Okay, are these ones in orbit? Definitely not stably. Okay, another collision with Earth. Another one. Oh, another one. Oh, more. They're all hitting Earth over time. I think we might be left with Earth in orbit and some weird elliptical moons after this. Oh, Earth got hit again. But it is still in orbit this time. Oh, something just happened. What just happened? That just flew it out of the solar system. That is crazy. It is going straight down, never to be seen again. Okay, and for our final suggestion today, it is delete the planets, but let their moons orbit the sun. Okay, this is actually kind of cool. So let's just try it with Jupiter, because Jupiter has the most moons. So let's add its moons. Okay, so here's all of Jupiter's moons. You can see there's a lot, a decent amount. So if we just delete Jupiter, what's going to happen? Are they going to fly out or are they going to start orbiting the sun? Let's see. Go. Looks like they're all going to orbit the sun. You can see those are that's their orbit. Let's go their trail. So if Jupiter, okay. A lot of them are actually flying out. A good chunk of them are starting to kind of form like a new asteroid belt and fly around the sun. Io is gone. Callisto is gone. So Europa is gone too. So a lot of the main ones are gone. But a lot of these smaller ones kind of join the asteroid belt. And you can see they all meet up where I deleted Jupiter. And then they kind of spread out and then all meet up there again. Wow. Okay, I'm going to do that with all the planets. This is going to be a lot of particles because there's a lot of planets. So if I just go and delete all of the planets, but not delete the moons. Jupiter, delete. Saturn, delete. Uranus, delete. Neptune, delete. And then playtime. We'll see how fast I can run this simulation. Oh, okay, you can see all of the planets and their moons a lot of them are being shot out, but a lot to start orbiting the sun. And if we let this run long enough, like millions of years, I would assume that a lot of these would start colliding and we could even see new planets form. So after lots of years, a lot of them fly out, but a lot of them start orbiting the sun. We have a lot of little planets now, basically. Okay, our next one's kind of a fun one. It's terraform a moon and then give that moon a moon and see how the orbits react to each other. So let's pick a moon of a planet here. Okay, I think I'm gonna pick one of Jupiter's moons. It has a lot, you can see those. Let's do Ganymede, why not? Okay, and we are in the new update, so this might be different than kind of what I'm used to. I'm gonna try just adding water to start. Ganymede's the biggest moon in the solar system, so this is going to be perfect for giving a smaller moon. Oh, look. The primary thing is oxygen, so I think this is... No, it is a water ocean. Okay, but look at that. That's a perfect coverage, I think. It does have some oxygen on it. You can see that here. If we just add an atmosphere, we're going to have to actually pick the minerals. Okay, let's go 1 Earth's atmosphere, and then we'll lower it a little bit because it's not as big as Earth. Whoa, okay. It's all blue. Why is it all blue? Okay, is there a way to pick which materials are in the atmosphere? No. Okay, oh, there's actually no atmosphere anymore. Here, we're gonna have to do this manually, I think. So we're gonna set this to 0 and then start adding nitrogen. Oh, maybe not that much. Because nitrogen is the main component of Earth's atmosphere. But then we also need some oxygen. Whoa, Why is it adding so much? Okay. What's our life likelihood at? Hey, it's not 0. Okay. I don't know how to deal with these new atmospheres. It's going to take some getting used to. We have oxygen and we have nitrogen. And we're going to need some water. We already have water. Okay, I'm going to manually kind of do this. Okay, I'm kind of cheating with this atmosphere. I don't know for sure how to really make these. Okay, I'm going to set the temperature to 5. What are we at? 3? I made it go lower. Okay, 4. Okay, we're going to leave it. I'm scared to touch it anymore. So now we're giving Ganymede a moon. So this is a moon of a moon. We're going to have to go random small moon. Maybe that might be too big still. Okay, we're going to go with this one. Okay, basically we're just trying to see if this is going to be stable. So let's turn on trails, yep. And make sure that Ganymede stays in orbit of Jupiter. Yes, okay, this actually does look stable. It's really hard actually to put a moon of a moon. Just for fun, I'm going to try to put something really, really small in orbit of this to see if that's even possible. Like a banana. No, see, it's really hard because Ganymede pulls on it too. So Jupiter is pulling on both of these, but the difference in strength is big enough that Ganymede holds onto it. That was a cool suggestion. Terraforming is actually a lot harder, but let's go to the next one. All right, Lively Space says, you should make a planet with the solar system as its moon. Oh boy, okay, we're gonna see if this is even possible. So we need a really, really big planet and then make the entire solar system orbit the planet. So I'm gonna start with Big Boy Planet, which is a planet I made. It should work if we make it 2 masses of the sun. Oh, that turns it into a star. Okay, I'm gonna use a black hole instead of a planet because I know that will work. Okay, here we go. Here's a black hole. And the size of the black hole isn't even that big. It is only 4.6% as wide as Earth. So, but it's so dense, that's why it works. So we're gonna have to orbit we're gonna have to go pretty far. Okay, here's the sun as a moon of the black hole technically, and then we can go to actions and add planets to star. And there we go. So here's all of the planets. The solar system is now a moon of this black hole. Perfect. All right, and our final suggestion for today says you should make a habitable moon and a non-habitable planet and then crash the moon into the planet to see if that'll make it habitable. That's a good suggestion. So we're just gonna make a quick system. We'll just use the sun and then, okay, I'm not very good at terraforming, but we're gonna try. I think I found a cheat way to terraform if you just launch Earth into whatever you're trying to terraform. Because Earth, you know, is good for life. So, I don't know, launch a few Earths into this and see if that'll terraform it. I mean, it didn't make it worse. Okay, well, so we actually need to terraform this planet by launching a habitable moon into it. Okay, what's the chance of life on this? 0. Okay, so this is going to be perfect for us to try to terraform. So if we put a moon in orbit here, we don't want a super big moon. Okay, we'll try this. So we need to terraform this moon now. But just adding an atmosphere doesn't work. You got to manually do all this. We'll go 70% of the atmosphere nitrogen. I think that's pretty close to what it is. And then what, maybe 5% carbon dioxide, 10% oxygen. These are just guessing numbers, honestly. And then there's some other stuff in there. And then we are going to, I don't know why the atmosphere is so blue like that. Let's add some water to it too. There we go. Okay, let's see if I can actually get a successful terraform. How does that work? 3.8. I mean, moons are hard to terraform just regularly. Rotational period, set this to 1 day. Set the temperature to like, I don't know, 10 Celsius. How's that? 6.2. Okay, we'll take it. Well, this is at 0. So if this has any percent above 0 after this, then I'll consider this a success. So we just want to launch this into the planet now. Right here. Okay, we're going to launch this into this planet now and see if that can bring us any habitability at all. Because that did have a small chance of life, 6%. Well, obviously it's not going to be habitable when it's burning hot. Let's give it a few years to cool down and let's see if it's above 0. It is above 0, 0.0003. So, I mean, I guess it kind of worked. I bet you could do it better than I did, so try it in your games. Okay, our next suggestion says, put a lot of rings around the Earth and then throw meteors at it. Okay, so we're gonna need Earth to have a lot of rings, whatever that means. We're gonna add Saturn-style rings to it. They won't be the same size as Saturn because Saturn's rings are very big. Okay, there's Saturn style rings on Earth. I actually want them to be in more, so we'll bring it in. There we go. Okay, so now it has like a fully completed ring. So now we have the issue of we have so many particles in the game that it's hard for the game to run it all smoothly. Which is not going to be helped by what we're about to do by throwing a bunch of asteroids at Earth. Okay, I want to like line it up with the rings like this and just like start throwing some asteroids at the Earth. Okay, we need something big too. Like let's throw the moon at Earth. Okay, here we go. We'll see what happens with all these. These are on their way with our almost 0 frame rate, and we'll see how the Earth survives. Yes. Okay, so some of the asteroids. Oh, the moon got hit by one of the asteroids I threw earlier. So now it's like a flaming hot moon. And here the moon comes. Okay, we're gonna want to slow down time here. Oh, there was the collision. Okay, let's see how Earth's rings get affected by this. Oh, you could see like a trail where it kind of cut through. You can see it right here where it disrupted the rings because of the giant moon flying through. Okay, let's see how the rings, if they survive this. So it looks like, yeah, look, a lot of them are getting thrown out of orbit because they're not designed for that. Now it looks like a whirlpool almost. It kind of looks cooler. Okay, I want an even bigger disruption to these rings. Let's throw 5 moons at the Earth. We're gonna make them all go at the same time, and we'll see how this affects the Earth and its rings. Okay, I think I'm at more than 5 now, but we're still gonna do it. And go. Okay, here a bunch of moons come. Let's see how this affects everything. Oh, it's slowing down itself because there's so many particles and things happening. 2 of the moons collided. There goes 1 into the Earth. There goes 3 more, 4. Oh, and all of the rings, look, they all get launched away. What is happening? Whoa, where did all the particles get like pulled away by these moons, it looks like? And this is still the fastest I can run it. Watch, as soon as I clear all the particles, the game will go like super fast. Clearing, unless it crashes the game. Oh, yep, see, and it goes super fast. Okay, our next suggestion comes from QU Empire saying, try making a sun bigger than the Milky Way. So we're gonna attempt this. Let's turn off the Milky Way background because we're gonna make something bigger than the Milky Way. We should be able to do it if we just pause the simulation. So let's take the sun, put the sun in here, and then pause. Just spacebar and pause it, and then go to radius, change it to Milky Way, and make it 1.1 Milky Ways. Zoom out. I'm still zooming out. Zoom. Okay, radius of galaxy. So now if we put the Milky Way right here, you can see that the sun is now bigger than the entire Milky Way. So now we're gonna unpause it and see what happens. Instantly, it collapses in on itself, unfortunately. But if we speed it up and see what happens, it looks like it just dissipates. So we did it, but it can't really survive like that. Unusual Dominic says, could you create a planet that has a survivable day with a freezing night that freezes the water and land? So we need a planet where the day you could live on, but the night it will freeze. So to do this, I'm gonna use the sun as a star and then add a random rocky planet about 1 AU away, which is about the distance from Earth to the sun. And to do this, I think we could just terraform it and then make the rotational period really slow so the cold side stays cold for a long time. So let's start by adding some water to it and then add an atmosphere. And let's make it look prettier. Let's add city lights on the back. Add some vegetation. There we go. This is looking like a pretty good planet. So now we want the day side to be habitable and the night side to be really cold. So in motion, what I'm gonna do, I'm gonna make its rotational period even slower. So this is how long one day is on this planet. So it's about 122 days now. So it takes a long time for it to rotate. So if we check out the surface, it looks like it's working. The back of it is getting pretty cold. Maybe even slower on the rotational period. We want, yes. Okay, so it's working. So this is the daytime and you can see that it's very hot right here, but you could live. And then on the back right here, it's getting really cold and the oceans are starting to freeze.
And if we check our overall habitability, it's at 21.4, which works for me.
Okay, our next suggestion says, give the sun another asteroid belt, but make it vertical. Okay, so we're actually going to use the same system here. So I cleared the old asteroid belt. So we still have our reverse system here. And we're going to go to asteroid belt and then change our settings on it and make it so it's vertical. Okay, so I think if we just, okay, let's add a really thick asteroid belt. Okay, so you can see it there. And I think if we rotate the sun, it'll actually rotate the entire asteroid belt too. So you can see it there in the background. Oh, no, I'm not trying to move it. Rotate. Oh, yeah, look, check that out. Okay, so if we just rotate, we can rotate the entire asteroid belt to be vertical. Okay, that looks awesome. Looks like a giant ring. And I don't think this will really affect all that much, but that, it looks like, whoa, you like go really far away. It almost looks like an eye right there in the center. Okay, our next suggestion says combine Venus and Mars and terraform the combination. Okay, where is Venus? Venus is here and Mars is here. So I think our best bet will be to combine Venus with Mars and then terraform that option. So we're actually just gonna delete the Venus that was here, go to our Mars, and then throw Venus at it, and then make sure that it's still orbiting the Earth. And then we can terraform whatever is left. Not good things are about to happen to Mars. Oh yeah, okay. So Venus obviously just completely absorbs Mars because Venus is it's over 3 times the size of Mars. Okay, we'll speed up time and see how Venus looks after. Let's make sure Venus is in orbit. Okay, Venus is in orbit. Perfect. That means we can terraform it now. So let's wait for this to cool down before we start to terraform it. Okay, perfect. So it just looks like Venus still. Its atmosphere is way too thick still. We're gonna have to fix that. Atmosphere mass. We're just gonna make it the same as Earth. Oh, and look, you can start to see Venus's surface and the water. That probably came from Mars because Mars has a little bit of water on it. That's a beautiful planet though right there. I kind of like the personality that it has. So we're not just gonna make a copy of Earth with this. I'm just gonna add some water to it and call it good mostly. Whoa, it almost looks like it has the surface of Mars underneath the atmosphere. That almost looks like Mars. I think it is Venus still, but it's been shaped by the Mars that collided with it. Okay, let's add, right now it has a 6% chance of life, which is honestly pretty good for everything it's been through. Let's go ahead and add some more water to the surface. Okay, so it looks like it's pretty flat and we just kind of have like a thin thing of water kind of everywhere. So it's like really thin water. I kind of like it though. How does that put our life likelihood? 16.9. Let's see. I think if I change its rotational period to be 1 day, that will help with that. Okay, I'm gonna stick with that. So our final life likelihood is 18.8. Not as good as I'd like, but it is kind of hard to get it good with this Venus model that we're using. So there is a terraformed Venus that has collided with Mars. Okay, our next suggestion is give the Earth a small Earth as a moon. Okay, so we have I don't even know what this Earth is. What happened to our Earth is it had multiple collisions, but then the spherical cow. Okay, we're bringing the sun back. We need the sun for life, man. Okay, and then so here is our Earth. It's been through a lot already. You can tell just by looking at it. Let's melt the water, and so we don't have just a ton of ice. Okay, well, it doesn't even look like it has any water on it, but that's okay. We will give it a small Earth as a friend. Earth. Okay, while it's paused, we'll put Earth in orbit right here. But then we got to make this Earth like 1/10 the mass, 0.1. And that should really help it be in orbit. But before we press play, let's make sure this looks exactly as it should. So it looks like our atmosphere is a little too thick. So let's turn that down. And what happened with our water? It looks like we need a tiny bit more. Yeah. Okay, maybe the atmosphere a little bit thicker. Perfect. Okay, so there is little Earth now. What's our life chance on little Earth? 70.2. So life probably still would exist on here, but what's our chance on this big one? Because this big one's been through a lot. 0. Okay, so this Earth has no life, and now the little Earth is the only one with life. So maybe these small people can one day get advanced enough to colonize the big Earth, where they came from. I don't even know. I don't know the lore of it. Launch Saturn at Earth, but from far away, and add rings. Press C to be on Earth's surface and watch as Saturn slowly gets close and close and causes havoc to the Earth. That's a great idea. Okay, so we're launching Saturn at the Earth, but we're gonna have rings and we're gonna be standing on the Earth while it happens. Okay, add Saturn's rings. Okay, we're gonna land on Earth now. Look up. There's Saturn coming. Now we speed up time and see what happens. Okay, I turned off the Earth's rotation just so we can watch it. Here it comes. Here it comes. Ah, slow down time. Turn off the clouds. Okay, I turned off the clouds. Land on the Earth.
There it is. You can see its rings. Oh, here it comes. And we're gonna die, aren't we? Oh no, oh no. It forces my view out, and now we are in space looking at Saturn. And how its rings survived. Whoa, do they have any disruption at all? Slightly, they're kind of like off-centered, but Saturn is pretty much fine. Wow, okay, Earth was no match for Saturn. Shoot all of Jupiter's moons into the Earth. Oh boy, okay. So here's the Earth for the like, I don't know, 5th time. Grab all of Jupiter's moons. Jupiter has like 90 moons, so we're just gonna do the main ones. So we got Io, Europa, Ganymede, and Callisto are gonna be the main 4. So let's put one there, one there, one there, and one there. Okay, so all 4 of these are about to crash into the Earth. Let's turn on a flashlight. And we'll watch them all crash in mostly at the same time because we're pretty much the same distance. Okay, Ganymede hits first, Callisto, Io, and then Europa. That is very bad for the Earth inhabitants. Okay, speed up time. How is Earth after this? So this looks a lot worse than when just our moon collided with the Earth. How is our life likelihood right now? It's at 60%, but it's going up. So let's wait a few years. It looks like it only caps out at around 86. So this did have a chance to make all life extinct. Looks like we have a little bit of land somewhere. Wait, where did all this water come from? There's a little bit of land there, it looks like. So it's probably all oceanic life now. All the humans are definitely dead now. All right, we got another suggestion to combine the Earth and the moon. So we're going to launch the moon into Earth and see what happens. Slow down time here. Okay, so here's the Earth and here's the moon. So let's just set the velocity of the moon to 0 and then see if it crashes into Earth. Speed 0. I don't know if it will. Oh, it looks like it's coming. Oh, it totally will. Okay, so this is what would happen if the moon just suddenly lost all of its speed. It would crash into the Earth. Oh, it's coming. It's gonna hit Africa. Okay, coming right into Africa. Oh, that's pretty big. Boom. Okay. Bunch of rock particles launch out and the entire Earth gets covered in this giant shockwave. Looks like it would burn every single person. So everyone would die. You would die. And speed up time. And a lot of these rocks are going to come back down and crash again, causing even more destruction. This is all like dust clouds and gas. Okay, so that's what happens if you combine the Earth and the moon. Let's see how Earth ends up after all this. So it looks like we got new continents. There's a supercontinent Pangea here. Type thing, and then a smaller continent right here. And let's wait for it to cool down like a good amount. And let's see its chance of life after this. 85%, you can see it's still going up. So it would probably kill all life, but then new life would develop after. And we would have no moon, so that would mean no tides. All right, that's what happens if we combine the moon and the Earth. Okay, this one's gonna be fun to try. I don't know if it's gonna work, but it says make 2 negative mass black holes or white holes, which I've done before. And in theory, they should still be attracted. I don't know if this comment is real, like if it's gonna work, but we're gonna try it. So in Universe Sandbox, you can create a black hole that has negative mass, and that turns it into kind of a white hole where it repels things instead of attracts them. Okay, we're just gonna do a black hole the same mass as the sun. We'll put it right here. We'll put a good background on for this. Okay, so if we set the mass instead of 1 sun to -1 sun, that will make it start repelling things. So if I put Earth next to this, you can see how small it is, but put Earth next to this, you can see it immediately just got flung away. So we're also gonna make this white. Okay, so I have the white hole now. We're gonna put one right here and just put one right here. I think that they're gonna get pushed away from each other, but according to the comment, they should be attracted. Let's see. Okay, I don't even know what happened. Wait. I think it might have worked. Okay, I need to do that again, but slow motion. Pause time. Put one here, put one here. Each one is -1 sun mass. That's correct. Okay, we're gonna go really slow time. Let's go real time. Whoa, okay, that was real time. That's how fast they were pulling, but I'm pretty sure it did. It combined it, and now it's -2 suns. So there still is an attractive force. Okay, I gotta do it again, but super slow. That was real time, you saw it. Okay, so how fast? 1 millisecond per second? Okay. Now they're being repelled? What? I am so confused, actually. Wait, why does it say that they're... How did it combine when it was going fast? But if I go super slow and then...
It just combined there? What? It like repelled, and then there's a point when it just combined even though they weren't touching. I am so confused, actually. I don't know if this is, maybe I'm using the preview version and this is a bug, but look, 1 millisecond, they'll start traveling away from each other. You can see that. And then there's a point where one of them disappears and it's just inside the other one. Yeah, okay, I think if you turn up the speed fast enough, then it does it. Or not. Oh, see, it just happened. So it might be a speed thing, I'm not sure. Might be because I'm on a preview version, but technically they combined, but they were moving away. I have no idea. Let's go to the next suggestion. Okay, we're back with a fresh solar system. Okay, and our next suggestion is to add an asteroid belt between Earth and Venus and make it go crazy, whatever that means. We'll have to figure that one out. Okay, between Earth and Venus. So like right here. Okay, so to add an asteroid belt between those two, we're gonna have to go, in Universe Sandbox, they count it as a ring. So we can go and add asteroid belt, but then if we change the settings of the asteroid belt, okay, so we'll set our inner radius to 0.7 AU because that's how far Venus is from the sun. And then we set our outer radius to 1 AU, which is how far Earth is from the sun. Set our particles up here. So this should make an asteroid belt that is perfectly between Venus and Earth. And if we put this on here, yes, you can see it worked. And it's a little bit tilted actually, but that should be okay. So you can see that it starts right where Venus's orbit is and it ends right where Earth's orbit is. So let's go to Earth and see, okay, wait, it looks like it's flattening. Oh, whoa, okay. So it looks like stuff is happening to it. So this might be the crazy they were talking about, even though I didn't do anything. Look, it like shrinks. So now it's like flat right here. And then it, okay, look, see all the particles, where are they going? So there is the asteroid belt. Hey Chip, can you make a star binary with a black hole and then add planets to the system? Yes, we can do that. Okay, so let's grab a star. Let's do random known star. How's this one? A little bit bigger than the sun. Yeah, that'll work. And then if we want binary black hole, we do a black hole 1 solar mass. So these are similar in mass, and then we just do binary. We'll go out here probably. Okay, so now the black hole and the star are orbiting each other like this. You can see that. And then if we select both of them and then create a barycenter, this will show the middle of their orbits. So they're both orbiting around this point. So if we add a planet around this point, it should work. So let's try adding a random rocky planet. We'll go about 1 AU away from the barycenter. Let's see how that orbit works. Wait for like a year on that planet. And that looks pretty stable. Okay, so we got a star and a black hole orbiting each other and then a planet orbiting those. So let's see if we can make this planet habitable around this black hole and star binary system. Okay, so we're going to start by adding some water. We'll go fill up like all those lower areas so it looks similar to Earth in water to land ratio. And then we're gonna add an atmosphere to it. What's our mass on this right now? About 26% of Earth. We're gonna change that to about 80% of Earth. And that'll put its radius at almost the same as Earth. So it's about the same size as Earth. The gravity is going to be a little less on it. But let's add an atmosphere. We'll go similar to Earth in how thick it is. Okay, that's already looking pretty good. I bet we have a chance of life already. Yeah, 41.9%. So let's change some of our other settings. Rotational period, we want that 1 day. The tilt on it, that's a super extreme tilt. So let's maybe do more traditional, just slightly tilted like that. So we still get seasons, but it's not super bad. Let's add a magnetic field. There we go. So you can see that magnetic field now, and we can turn up the strength to kind of protect it even more. So this will protect it from solar radiation coming off the star, from like ripping away the atmosphere and other things like that. And that puts us at 67.8% chance of life, which is pretty high. How's our temperature on here? Negative 43 Celsius. If we put that at 14, that'll be a lot nicer to live on. 14 Celsius is 57 Fahrenheit. That puts us at 75.3% chance of life. Let's give it a small moon now. Something like that, just for the tides and stuff. Let's make it a little bigger. Similar in size to our moon. We'll make it 80% of our moon, so it's like the relation is about the same. Okay, so here's our moon. It looks kind of dark, but I kind of like the way it looks. And that is going to be in orbit around our black hole life planet. And that is all in orbit around it looks like it's gonna leave, but it really won't. That is an orbit around a star and a black hole orbiting each other. So let's watch 1 year of this and make sure that it is still stable. We're gonna watch our planet go around. Yes, look, it's working. So if a black hole and a star were binary with each other, you could still have life on that planet. Could you change the black hole in the center of the Milky Way galaxy? Let's try.
Okay, so here's the Milky Way galaxy. Let's see if we can focus just on Sagittarius A. Yes, okay. So now we can focus on the black hole in the middle. So let's try to make it more massive and see if it'll eat the entire galaxy. So let's spin it up fast enough that we can see the galaxy spinning. So that's going to be like millions of years per second. Yeah, there we go. Okay, so you can see it's moving. And let's just start turning up the mass of the black hole and see what happens. Okay, it's growing right now. Growing. Oh, it's working. It's eating stuff. Okay, it's like eating everything in the middle. Keep going. Suck more. It's like condensing the whole galaxy into a smaller galaxy. Bigger. Oh, it's starting to shoot stuff out. We're like giving it an accretion disk. And I made it. Okay, the entire galaxy like disappeared. So either everything got sucked up or shot back out into space. Maybe try the smallest black hole next to Earth and see what would happen. All right, so here's Earth. We can really make a black hole as small as we want. Let's try to make a black hole that is 1 centimeter big. So, you know, that big. So I'm actually gonna take the Earth. We're gonna make it paused. Put the Earth right here and then turn this Earth into a black hole. Shrink down. So here's the Earth now. The mass is not changed. So this and that Earth there have the same exact mass. So we want this radius to be 1 centimeter. Okay, that's 8 centimeters. 7, 6, 5, 4, 3, 2, 1. Okay, 1 centimeter. So that means that it needs to be even more massive to turn into a black hole. We're gonna lock the mass. Okay, there we go. Tiny black hole, only 1 centimeter big. So let's actually put a human scale object next to it so you can see. Here's a soccer ball next to our black hole. So you can see that our black hole is very small. And we're just gonna play time and see what happens. Okay, I'm gonna speed up time a little bit. It looks like, okay, I'm zeroing the velocity of the Earth. Okay, here we go. They're getting pulled towards each other. Oh, it's pulling giant chunks off the Earth before it gets there and sucking up these giant rocks. Okay, after it eats all of those, how big is it now? 1.14 centimeters, so it's bigger now, but not by a lot. It's about to hit the surface. Oh, and it just instantly ate the whole thing. And now it is 2 centimeters big. We're gonna start by putting a moon that has a moon that has a moon with a moon. Okay, so we definitely need a star to start. So let's just do a random known star for this. This one's almost twice the size of the sun, but that should be fine. So I think if we're gonna want as many moons as we can, we're gonna want to do a gas giant. So let's do a pretty large gas giant. Like maybe 50 Jupiter. Okay, that starts it turning into a brown dwarf once it gets that eye. We'll do 30 Jupiters. No, it's still heating up too fast. Ah, it's heating up too fast. Density down. Okay, I think this will work. Okay, now, so this planet has 4.3 times the mass of Jupiter. So this is what we're gonna use as like our home planet. And then we're gonna try to put a moon with a moon with a moon with a moon. So we're gonna start, let's do like a pretty big object for its first moon. Like maybe even another gas giant. That work? Yes, it still counts it as a moon. So let's see what our orbits are looking like. It might be a little bit binary. No, that looks like a perfect orbit of a gas giant around a gas giant. So this gas giant still has the mass of 7 Earths. So now let's give this gas giant its own moon. What if we did Earth for its moon? How close do we want it? Maybe this far? Let's see if that works. That does not look like it's going to work. So if that doesn't work, we might need to go even smaller to start. Let's try to do Mars for a moon. Okay, that looks like it's working better. So we have this gas giant, which has this moon, which has Mars as its moon. And then now Mars needs a moon. Let's go with random. Let's try to do Phobos, because Phobos is already Mars's moon. No, that didn't work. We might have to go super, super small to get this one to orbit. Like that? Oh, that just crashed into it. It's like the gravitational pull of this larger object is gonna stop this from working. What's like the smallest object we could do? Like a watermelon in orbit around Mars. Even the watermelon doesn't work and it shoots out fragments of Mars. A watermelon really close. How about that? See, the pull of this object kind of ruins the orbit and then it just crashes in. That watermelon must be going so fast for it to do that to it. Okay, well, that looks like a lot of little moons. So we're gonna count that as a moon in a moon in a moon in a moon. Maybe. Good enough for me. Earth is back. Wow, for the 3rd time? Launch a sperm whale at the speed of light at Texas. Oh boy, okay, where's Texas? It's gonna be like right here. So let's get the sperm whale object. Boom, right here. Okay, sperm whale, launch At the speed of light. Okay, so there's Texas gonna be about right here. Here's the tiny sperm whale. I mean, it's pretty big compared to a human. You need to be like a dart. We need you pointed at the earth, ready to strike. Boom, the whale, he's ready. Look at him. And then where's our speed? Motion, speed. Okay, light speed, let's set it to 1. Okay, we're gonna need our time to be like real time. Okay, this is real time. So we're watching this unfold as if it were to actually happen. Oh, I guess light speed's too fast. So you saw that it did impact right there and just, I paused it like immediately, but you could see the shock wave starting to spread already. So this is a sperm whale impact on the earth. It shoots out and I'm sure that would have not have been good, but it looks like it's mostly okay. So let's do it even faster. Okay, so technically this isn't mathematically or physically possible to go faster than light, even to get to light, but we're gonna go, how about 100 times light speed? So let's set the time to like 1 millisecond or like less than that. Can we even go less than that? Okay, this is 0.1 milliseconds every second. So this is how fast our sperm whale is going towards the earth. Wait. We gotta rotate it so it's a dart. Pointed at the earth, pointed at its target that it's going to attack next. Okay, we're going towards the earth now. Sperm whale round 2. Here we go. Okay. Oh, already you can see the circle of where it impacted, but the time's going so slow, we're gonna have to speed it up to see any real damage. There we go. Okay, we got our first thing. That's it. That's even less than the light speed one. How fast do we need to make it go? Okay, we need something bigger. Giant sperm whale time. Oh yeah, there we go. That's perfect. Okay, we're just doing a normal speed. We don't need light speed for this giant whale. Here we go. Giant whale versus Earth. Let's see. And it just ate it. The entire Earth is now inside the sperm whale. And it went up in mass. Oh, and it started spinning. Can we spin the sperm whale to death like we did with the other things? Make it spin. Spin the whale. No way this works. It'll just spin really fast, I bet. It's spinning very fast. Spin acceleration. We need this faster. Yes. Oh, we broke the game. It says not a number. Okay, so it is spinning. So this is real time. Let me put it in real time. That is the spin rate. Now can we like launch the Earth into it and then have it shoot the Earth out? Or is this not going to work? It's a terrible idea, isn't it? There goes the Earth into our spinning whale. Come on, come on. I want something cool to happen. And no, it just gets eaten by the whale. Wait, where did the whale go? Wait, where's the rest of the solar system? Somehow, oh, it did. It launched the Earth out of the entire solar system. Okay, here's the sun. So here's the entire solar system in just a few seconds because the energy is so high. The Earth is all the way out here outside of the solar system. That's crazy. Okay, and our next suggestion asks if we can make all the planets disappear and make it so there are only moons. Okay, so I opened a simulation that has all of the moons for all the planets. So there's actually a lot. Like this is Jupiter. You can see how many moons it has. So let's start by deleting Jupiter. We're gonna keep the game paused while we delete each planet. Saturn, delete. Mars, delete. Earth, delete. Venus, delete. Mercury, delete. So you can just see like there's Phobos and Deimos, there's the moon. Okay, Neptune, delete. Uranus, delete. Pluto, we can leave because Pluto's not a planet. And now let's play time and see what's gonna happen to the solar system. I don't know how fast we can run it because there's a lot of objects. Okay, so it looks like a lot of the moons just immediately start heading for the outer solar system. And some of them start to orbit. I guess it depends on where they were in their orbit. A lot of things are heading out of the solar system completely. So this is after years and years and years though. So it does look like it's a very chaotic system now, and we have a lot of small moons just orbiting the sun now. So I wonder if you could simulate super long time periods if some of these would collide together and make new planets. The current fastest we can run it is only 4 years a second. So there's not really a way for us to simulate millions of years like this. That is what would happen if all of the planets suddenly disappeared. And we're gonna start by flipping the order of the planets so that like Pluto is first, then Neptune, then it goes all the way back and Mercury's at the very end. Okay, so here's our solar system right now. So you can see that Mercury's at the front and Pluto, where's Pluto? Pluto's all the way here at the back. So we're gonna switch them. So I think the best way to do this is gonna be to start a new simulation and just kind of rebuild it. Okay, so here's the sun, we'll put that in here. And then we're gonna start by putting Pluto really close. Pluto, we'll put
Right there. That is very close to the sun. I think it'll actually start to burn up. We'll check on it again in a minute. Okay, then it's going to be Neptune. So Neptune we'll put about right here. Then Uranus like here. Okay, Saturn here. Jupiter's a little bit further than Earth is from the sun usually. And then there's a big gap here. Mars will be about 5 times the distance between Earth and the sun. And then Earth is going to be all the way out at about 10 AU, which is 10 times further than it usually is. I wonder if life will still be possible. We'll have to check on that. Venus usually is super hot. So let's see if it's still super hot out here at 25 AU. And then Mercury, we're going to put a solid 50 AU out. Okay, so here is a reverse solar system now. Let's re-add the asteroid belt. Check that out. Okay, so now the asteroid belt is still between Mars and Jupiter like it's supposed to be, but now Jupiter's on the inside and Mars is on the outside. Okay, that's pretty cool. So let's check on Pluto and see. Okay, the temperature is still rising. We're gonna need to run the simulation a long time to see any real effects. Yes, look, it's totally burning up Pluto because of how close it is. I wonder if we speed it up enough. Oh, that is so fast. Okay, so it looks like it's stabilizing at around 1,000 degrees Celsius. That is how hot Pluto is. That is crazy hot. You can see it is shooting off matter. So I think over a very, very long period of time, Pluto might be completely gone. Let's check on Earth. So it looks like the oceans are still here. Saltwater needs to be colder than freshwater to freeze, but all of the continents have completely frozen. It is still cooling down, so I do think eventually even the oceans will freeze. Right now, our life likelihood is at 90% still. So I'm gonna run it as fast as I can and see how low it gets. You can see it dropping there. Okay, it's running at about 6 years every second. It's still dropping. We're almost at 60% now. So I think it just means any life. So humans are most likely dead, but there could be like bacterial life still underneath this ice. I think that is very possible. Oh, and there it went to 0. Okay, so after a long, long time, after 330 years, all the life would be dead. So if this randomly happened, there is a good chance that maybe you could live the rest of your life and not die in like a bunker or something. It'd be interesting to see to what extent humans would go to survive that. And let's see, like, is Neptune burning up or is it just far enough away? Oh, it is. Look at that. Neptune's got some orange bands, it looks like, but it's really just fire on the planet. And Uranus too? No, Uranus looks good. Oh, there does look like there's some fragments. Most of the planets are okay. Pluto is not okay and the Earth is not okay, but the other planets, there's not much on them to be affected even. Like look at Mercury, it looks exactly the same, except maybe your sunlight isn't as much. So that is the solar system in reverse order. I want to thank you all for watching my channel this year. And thank you again for 500,000 subscribers. There's going to be lots of new content coming next year, so make sure you're subscribed. Also, thank you to my channel members, as their support helps me out a lot. I will see you all in the next video.